Hi, and hello. This is Dr. Mandic. Welcome back, everybody. We are continuing to talk about metaphysics, and this lecture is going to be all about the metaphysics of time and some closely related topics: change and causation. Once you start thinking about change, you realize that you couldn't have change unless there was time, and you might wonder if it goes the other way too. That you couldn't have time unless there was something changing. And we're also going to be talking a bit about causation. Causation is really a very weird topic. We got into it a little bit when we were talking about Hume in the empiricism lecture about what causation is and whether we have a clear idea of causation. And there's some strange stuff about causation when you get into time. Some of the stuff that we talk about in the metaphysics of time has to do with things like time travel. And if time travel, especially traveling back to the past, is possible, then it looks like you've got examples of causation that are very strange. You've got events that are in the future that are the causes of events that are in the past, effects of future events. So causation is going to be coming up again, and what we're here mainly to talk about is time, and that is specifically the metaphysics of time. Now, you'll recall from earlier lectures that metaphysics is the branch of philosophy that studies reality and the nature at the most fundamental level of things. So the nature of space is something that we got into in our previous lecture. And one way of putting what the metaphysical issue or issues are concerning time is to ask a question about reality, the reality of moments in time. So one way in which we think about or talk about time is with respect to various moments in time. And there's three big divisions when we divide up the moments in time, and that is the past, the present, and the future. So right now is the present moment, and you might think that the present moment, that's definitely real. But is there anything else that's real with respect to time? Like, how about the past? Is the past still real? People say things like the past is done and over with. You can't change the past. It's over now. And you might wonder if the past is still there. Is it still happening? Or has it faded away and it's not real anymore? If it's not real anymore, then it's somehow less real than the present. And how about the future? Is the future real? We're going to be looking at some views that say things like that all moments in time, past, present, and future, are equally real, just the same way that there are multiple regions of space that are real. Where you are is what you might call here, and you might think here matters the most to you, but you probably don't think that other regions of space are less real than here. Well, by analogy, are other moments in time less real than now? Maybe they're equally real and in some sense always have existed and always will exist. So that's the sort of thing that we're going to be getting into. We, as contemporary people living in a technological age, are very familiar with photography and the way in which a photograph can capture a moment in time. We usually experience time as flowing and changing, but we also think about time as having these moments, these distinct moments, and a photograph catches a moment in time. And if you think about it, you realize that every photograph is a photograph of a past moment. So here's a photograph of a past moment, and in that moment, there was this baseball that got hit into the stands, and several people are trying to catch the baseball, and several people are not yet aware that there's a baseball coming at them, and others are trying to get out of the way. And in one sense, like, this moment is done and gone. I'm not sure when this photograph was taken, but I bet a lot of the little kids that are in the photograph are probably adults now. Those little kids, in some sense, are gone. They're not little kids anymore, and this moment is gone. And you might say there's some other sense in which it's still real. One way of thinking about this is in terms of the correspondence theory of truth. The correspondence theory of truth says that true statements have to have something outside of them that they correspond to that makes them true. So here's a statement. The blonde lady was about to catch the baseball on October 21st, 1994. And that statement's true. What makes it true has to be something that exists. The statement's true now, so there has to be something that exists now that makes it true. So in some sense, then, there has to be this past moment that still exists in order for that to be true. And if the past doesn't exist anymore, then how can statements about the past be true? So when we think about the correspondence theory of truth, a realistic theory of truth in general, and we start thinking about statements about the past, we start thinking maybe the past has to, in some sense, be real. And a similar sort of thing applies to the future, and this was the example of the sea battles that we had discussed in an earlier lecture. If I say there's going to be a sea battle tomorrow, well, that's either true or false now, and so there has to be some fact of the matter, something going on in the future already to make it true or to make it false. Okay, so here's what we are going to talk about in this lecture. A whole bunch of things that have to do with the metaphysics of time. The first and maybe most important is you're going to learn some terminology distinguishing two kinds of theory about the metaphysics of time. One kind of theory is called the A theory, and the other kind of theory is called the B theory. And I didn't make up these labels. If I had made up these labels, I would have come up with something a lot easier to remember than A and B. A doesn't stand for anything. B doesn't stand for anything. That's just like there's this one theory of time, and there's this other theory of time, A and B. Sorry about that, but you got to learn it. And once you start learning it, I hope you'll appreciate it. It's really cool and really interesting and really weird. So there's this general distinction between two ways that philosophers think about the metaphysics of time, whether time is the way A theorists say it is, or whether it's the way that B theorists say that it is. These issues about the reality of different times lead us into the question of time travel. If the past and the future are in some sense real, even though they're not now, well, then they're there to be traveled to. And in theory, you could go back in time, or you could go forward in time. And other people have said that you can present philosophical arguments to show that that's impossible. And keep in mind, we're doing philosophy here. We're not doing science. The question is not, is it scientifically or technologically possible to travel in time? But could you have a priori knowledge, just by using reason, to prove that time travel is impossible? Some people have argued that if time travel is possible, that would lead to certain paradoxes. That would lead to certain logical contradictions, which of course is absurd. You can't have a logical contradiction in reality. And so therefore, in reality, there's no such thing as possible time travel. Time travel would then be impossible. So we're going to look at some proposed paradoxes of time travel and some proposed solutions to those paradoxes, and the general issue of whether time travel is possible, whether we could know a priori that it is possible or that it isn't possible. And then we're going to relate some of the topics from the paradoxes of time travel to some of the topics comparing the A theory and the B theory, and get a glimpse of how the B theory views time travel and its philosophical possibility. So let's jump in with this first and biggest topic, and that is the contrast between A theory and B theory. So I first want to say some general things about what aspects of time we're even talking about. So first, let's talk about two different sorts of things that you might wonder in a philosophical frame of mind about time. And that is something that I'm calling the dynamics of time and the topology of time. There's all sorts of things you might wonder about time, but one of them is the dynamics of time. And dynamics is a fancy word for change. What is the way in which time changes? And a related question, does it even make sense to say that time changes? You might say it's obvious that time changes. That's why you wear a watch, because like the goddamn time is always changing. You're wondering what time it is now. But there's some really powerful arguments that the idea of time changing doesn't make any sense. Things change relative to time, but time itself doesn't change. So that's the question of the dynamics of time. And then there's another question about what we might call the shape of time, or the topology of time. So there's this contrast between dynamics and topology. And that's just a fancy way of saying there's a contrast between issues concerning change and issues concerning shape. What is the nature of the way in which time changes, and does it even change? And then there's this other issue, which is what is the shape of time? What is its, in its most basic sense, its shape? And let's say some more about the shape of time right now. And some of this will remind you of things that we said in Lecture 7. And we're going to go over it a little bit more right now. So here's three main proposals for what the topology of time is. There's the linear proposal that, in some sense, time is just like a line. Now, literally speaking, lines are spatial entities, and we're here talking about temporal entities, entities in time or time itself. So this is kind of more of an analogy or a metaphor than something that's literal, but nonetheless, it makes sense to talk about whether time is more like a straight line, or instead is it more like a loop or a closed curve or a circle. That would be the proposal that the topology of time is looped. And finally, there's the proposal that the topology of time is branching. And we talked before about like how would you define these different proposals for the topology of time. And we got into this in the virtue ethics lecture, which is kind of cool. It's neat to see how metaphysics and ethics can interact. And we talked a little bit about the virtue ethics of Nietzsche, and Nietzsche was very attracted to the view that time has a looped topology, that the future will happen again and again and again, and the future will become the past, and the past will become the future, and everything that you've already done, you're going to do again, and you're going to do it again and again and again. It just keeps going around in one big loop. And that raises certain questions that are ethical, that have to do, in the broadest sense, with value. What is the value of life if everything that happened is going to happen again? And you might say it's got no value at all. That just sounds like a really bad deal. I hope life doesn't turn out that way, that I'm just on a song that's being repeated infinitely. But Nietzsche said, well, imagine you were able to look at that horrible proposal and say, you know what, bring it on. Wouldn't you be totally pumped up if you were able to do that? You would have to be a real tough cookie to be able to do that. You would have to be a very rugged, strong mind. And wouldn't that be valuable, to be that strong, to be that mentally strong, that you're not bummed out by the proposal that time is looped? And that was a kind of virtue that Nietzsche thought we should try to cultivate, to be an Ubermensch, to be a super person. But we're focused here on the metaphysics of the situation. What really is the nature of time? And there's a close related epistemological question. How would you know? How would you know that time is linear versus looped or branching? How would you know that for every pair of moments, one moment is earlier and not later than the other? That's what it means for time to be linear. How would you know whether instead that for every moment in time, so let's pick 2 points on the circle, every moment in time is both earlier and later. So if you wait a little bit, that next moment will come. And if you keep waiting, the previous moment will happen. And the moment that was in its future is now in its past, and vice versa with respect to the other moment. So for any 2 points on this line, for one of them is behind, but also in front of the other. But that's not true with linear time. It's not true that for 2 moments, one of them is both before and after the other. One of them is before and not after, and the other one is after and not before. That's what it means to be linear. And what it means for it to be branching is that there are some points in here where you've got, say, 3 points such that, let's call them X, Y, and Z, such that X is earlier than both Y and Z, but Y and Z are neither earlier nor later than each other. So think about a point right here on this like trunk of the tree, and then 2 points, one on this branch and another one on this branch, such that they are the one on this branch is directly above the one on the other branch. So this, if you're familiar with like science fiction stories where they talk about branching time or branching off into parallel worlds, parallel universes, a lot of times they talk about the branching happening during various chance events. So at this moment in time, there's good old Professor Mandic, and he is about to flip a coin. And then he flips a coin, and one of these branches is the reality in which the coin comes up heads, and the other is the reality in which the coin is tails. So let's say we're dealing with 12 o'clock and then 12:01. 12:01 with heads and 12:01 with tails. Well, 12:01 with heads is neither earlier nor later than 12:01 with tails, but they are they're both later than 12. So that's the kind of idea we're trying to give, a very like almost mathematical definition of what it would mean for time to be branching. So these are both, actually all three of these things are metaphysical proposals for the nature of time, for the nature of time's shape. But there's also this epistemological question. How would you know? How would you know that you were in time that branched versus the other? So let's just focus a little bit more on the branching time. So if you were in branching time, well, you're only going to be experiencing either this branch or that branch. You're not going to experience both of them. Let's pick one. Let's say you're going to experience this one. Well, how do you know there's the other branch? Maybe there isn't the other branch. You might say, well, I could get in a spaceship and I could travel to the other branch. But why couldn't those just be events happening in a single line? So like here you are, you're looking at a coin that is heads, and you look at the clock and it says 12:01, and then you get in the spaceship and there's some flashing lights and you get out of the spaceship, and now the coin is tails, and you look at the clock and it still says 12:01. Couldn't all those experiences that you're having be just in a linear timeline? It seems like the answer is yes. So it also then seems like there's no experiences that you would have that would tell you that you're actually embedded in a branching timeline. This is the sort of thing that happens a lot in metaphysics, as you get these proposals for the nature of reality that massively outstrip anything that you would actually be able to experience and you'd be able to verify, be able to really to know about. Anyway, let's back up a little bit. So I said there's two main topics about the nature of time. One has to do with whether time changes, and the other has to do with whether it has a shape. And then I got a little bit more deeply into the shape of time, or in other words, the topology of time. And now what I want to do is to say that, you know what, for here on out, for the rest of this lecture 13, we're just going to assume that the nature of time is linear. You might wonder about these other things, and that's cool. That's totally interesting thing to do. But to keep things relatively simple, we're going to be just assuming that time is linear, that's its shape. And now then we're going to talk about what its dynamics are. So dynamics, like I said, has to do with change. And in other sciences, you talk about like the dynamics of matter, and matter can change from phases to like being solid and liquid. That's the dynamics of matter. You might focus on a sample of matter. What is the dynamics of this gas? How does the gas move? Or what are the dynamics of the human body? But we're focusing on the dynamics of change, the general issue of whether time changes and how it changes. In this arena of the dynamics of time, there's a bunch of different philosophical options, and they're kind of cool to think about. So one way in which the dynamics of change might work is that there just aren't any dynamics, that time doesn't change at all. And that's something that gets lumped under what we're going to call B theories. So the general gist of B theories about the dynamics of time is to say that time doesn't change. There's a sense in which past, present, and future are just part of a big, like frozen, solid thing, like bugs that are frozen in amber, and the past is still happening, it's still back there, and the future is already happened and it's waiting, and there's actually no motion, there's no change. And you might say, that doesn't make any sense at all. Obviously there's motion and change. Well, don't let Zeno hear you say that. Zeno would say, no, it's just an illusion. And one way of appreciating it, the idea is that if it's true that the past and the future are real, that means that there are You have various past versions of yourself that they're still experiencing their moments, and you've got futures of moments of yourself that are already experiencing their future moments, and each one of those selves have an experience that's telling them that time is flowing or time is changing, and that's the way it seems to them. But in reality, there is no change, there is no flow. There's just this infinity of versions of yourself, each of which is experiencing their own moment, and they feel like that one is the most real one, and the ones that are in the future, they're kind of haven't become real yet. The ones that are in the past are no longer real. So you might say, sorry, no way, I can't accept that time is frozen and unchanging. Tell me, Mandic, about these other theories, because I don't like B theories. Well, let's look at the A theories. One version of the A theory is to say that, instead of this big frozen block that has all the past, present, and future in it, there's just this small thing, the present. That's the only thing that's real. We call this option presentism. Only the present is real. The future hasn't happened yet, and the past hasn't happened yet. So, with presentism, time is changing, because the present moment always has something different happening, something different going on. No matter how still you try to keep yourself, there's always just a little bit of change, a little bit of motion. Even when you, a scientist will freeze something, will bring it down to absolute zero, the molecules are still wiggling just a little bit. There's just never anything that is perfectly still, perfectly motionless. So there's always a little bit of change, and it's the present moment that is changing. So right now, I'm saying this, and a little bit later, I got my hands up and I'm saying asparagus, and just a little bit later, we shut off this video and we go do something else. Time is always changing. And here are some other versions of A theory, of the A theory of time. So one of them is called growing block theory. On growing block theory, the past and the present are real, right? So presentism says only the present is real. Growing block theory says that the past and the present are real, but the future isn't real. The future can become real as it becomes the present, and then eventually will become the past. And the block is growing because you get more and more past moments. The leading edge of this block is the present, and it is growing in the direction of the future. So kind of picture a candle that is melting in reverse. It would be like a growing candle, right? The opposite of that is shrinking block theory. Shrinking block theory would say the future and the present are real, and what's happening is that the past is being burned up. So this is like a regular candle. You start off with a candle, and then you light it, and it burns away, and you have less and less candle. So probably shrinking block theory is not very popular. And why is that? Well, I hope you appreciate in this philosophy class that all the various philosophical topics, they're all connected in some way. So you talk a little bit about ethics, and next thing you know, that leads you to metaphysics. We talk about virtue theory and the virtue theory of Nietzsche, and that led us to a metaphysical view about time being in a loop. Well, these proposals about the dynamics of time, they're very closely related to the topic of free will. So if shrinking block theory was true, the future is real and the present is real. Well, the future is real. That means that it's already set. Whatever is going to happen to you tomorrow is already set. And you don't really have any options. Nothing that you do now is going to make tomorrow be any different than it was already destined to be thousands of years ago. So you might say shrinking block theory doesn't leave any room for free will. And neither do these versions of B theory seem to leave much room for free will. So you might want to say, all right, I need the future to be open because I really want there to be a very strong sense of free will. That's true. But then that leads you with either growing block theory or presentism. And why might you prefer presentism over growing block theory or vice versa? Why would you prefer growing block theory to presentism? Well, that leads to other issues in philosophy. So, for example, some ethical issues like whether you should be punished for the crimes that you've committed, or whether you should be is gone. And um, why, like, what does it mean to make a vow or to promise something? Suppose um, I say to you, "Hey, I want your car," and you're like, "Well, give me $1,000, I'll give you the car." And I say, "Well, you give me the car, and I'll give you the $1,000." And I say, "That was in the past." That person that told you you're going to get $1,000, that he doesn't exist anymore, so I don't have to give you $1,000. Um, or suppose someone got caught cheating on their spouse, and you might say, "Didn't you promise not to do that?" You'd say, "That person doesn't exist anymore, the one that made that promise." So we have in our common conceptions of ethics all sorts of obligations, and these obligations are based on things that happened in the past. If you did something wrong, you are under obligation to endure a certain kind of punishment. Justice demands that. But if the past doesn't exist anymore, then in some sense it never really happened that you killed that guy, and so why should you have to go to jail for it? So you might think, okay, right, we need the past. We need the past to be real so that we still have obligations. We have a correspondence theory of truth that grounds our obligations to these past events that are really real still, even though they already happened. And we still get free will because the future is open. So this is the kind of thinking that connects things about like free will and ethics to this metaphysical issue about what the dynamics of time are, and you're led to the growing block theory. That's not the end of the story. There's a lot more to say about which of these are more preferable and what they even mean. But that's the gist of these two different kinds of theories, the A theories and the B theories. Speaking of time, an alarm I set for myself just went off, so I'll be back later. Hi, I'm back. It may have seemed like I wasn't gone for very long, but for me was a whole day. A whole day went by during that little break. For you, it was just a moment in time. We were previously talking about growing block theory and some of the arguments that might lead you to believe in the growing block theory, arguments having to do with considerations of free will and how you want the future to be open, but also considerations from ethics about obligations and how you want the past to be real in order to make your obligations end up being true, where truth is defined as the correspondence theory of truth defines it. And that brings us to topics that came from our epistemology unit, where we were talking about truth as a component of knowledge. So you might wonder what arguments might there be in favor of the B theories. And the B theories include eternalism, the view that the past, present, and future are all equally real, and everything that exists eternally. It doesn't just exist for a little bit. So you might say that even though Julius Caesar is dead and gone, he still exists because those moments in time that took up his lifespan thousands of years ago, in some sense, those past moments still exist. So Julius Caesar is eternal, even though he only lived for less than 100 years. In some other sense, he still exists eternally. And things that haven't yet happened, nonetheless, already exist. So there's a difference for a B theorist, like an eternalist. There's a difference between existing and happening. There's more to what exists than what is presently happening. And one version of eternalism is something called four-dimensionalism, and this is like a version of eternalism that is much more explicitly connected to contemporary science, especially physics. And some of you might be familiar with the theories of Albert Einstein, especially concerning his special and general theories of relativity. And you might have heard of this idea that time is the fourth dimension, and that space and time, according to the Einsteinian theory, aren't separate entities, but two aspects of a single entity known as space-time. And space-time isn't three-dimensional, it's four-dimensional. Space-time is four-dimensional, and time is the fourth dimension in this four-dimensional entity. And if you get deeper into this Einstein stuff, you appreciate that it's a little bit weirder than that. It's more than saying that you can add an extra axis onto your graph and call that the fourth axis. But it's saying that in some cases, time can turn into space and vice versa. And whether things happen at the same time or not depends on where they're being observed from or where they're being measured from and what their velocities are. And there's no absolute now. We'll talk more about that a little bit later. The idea of space-time as being four-dimensional is going to come up later. For example, when we talk about personal identity theory in a later unit. But one image to keep in your mind when thinking about eternalism is something that we might state in contrast with the block theories of growing block or shrinking block theory. So eternalism, you've got all of space-time is just one big block, and it's neither growing nor shrinking. It's got all the moments in it. So you've got this big static block, which we might think of as frozen. So the dynamics are not very dynamic. There's really no change to time. Where with these growing and shrinking blocks, there is change in time. Time itself is changing. It's either growing or it's shrinking, or there's this just constant change at this very small point, which is the present. Now, this vocabulary of A theory versus B theory is not very informative. There's nothing over here that starts with the letter A. It's just, why is it called A versus B? There's no good answer to that, except to say that we inherited this language from the philosopher J.M.E. McTaggart. The philosopher McTaggart's full name is indeed John McTaggart Ellis McTaggart. McTaggart showing up twice is not a typo. Anyway, let's just call him McTaggart. McTaggart had a pretty famous argument about time, in which he's arguing that time isn't real at all. And the way he develops that argument is by distinguishing not between two different theories, A theory and B theory, but by distinguishing between two different series, what he calls the A series and the B series. And you're probably familiar with the word series, and you've got an idea in your mind about what a series is. And here we're talking about two different series that you might create in ordering moments in time, ways in which time can be ordered. Just like you could order people, you could like get them to stand in a line, and you could order them by height. Everyone stand in a line with the tallest person at this end and the shortest person at the other end, and everyone arranged in an order that reflects their relative heights. Or you might have people line up by the alphabetical order with their last names. So if your last name starts with an A, you're going to be closer to one end of the line, and so on. But instead of talking about people getting in a line, we could talk about moments in time and the way in which they are ordered relative to each other. So that's what the A series and the B series is about. And this is where we get the lingo of the A theory versus the B theory. And I'll say some more about how the theories relate to the series. But let's just focus now on the series. What does it mean to think of time in terms of the A series versus the B series? Well, probably the best way for you to think about this is in terms of an aspect of language that you're familiar with, known as tense. You're very familiar with the idea of past tense, present tense, future tense. So, for example, with various verbs, just to focus on English, you could have past tense, and oftentimes you put an ed at the end of it. So, the seed was planted. Or I might put an ing on the end of a verb and say I'm planting the seed. That's the difference there between past tense and present tense. And there can be future tenses as well. And sometimes we use more words like I am going to plant the seed. But anyway, if you know multiple languages, you probably know the ways in which tenses operate in those multiple languages. am most familiar with English, although allegedly I know a little bit of French. And in English, there's all sorts of different ways in which you can mark the tense of language, different ways of talking about time. And they reflect the relationship between, on the one hand, when you are talking, and on the other hand, when the thing happened that you're talking about. So if it's right now, it's 2018, and I want to talk about somebody jumping on a trampoline in 2017, then I'm going to talk about that using past tense. I would say they jumped on the trampoline. But if it's 2018 and I want to talk about somebody jumping on a trampoline in 2021, I'm going to say something like they're going to jump on a trampoline, and now I'm using future tense. And if I want to talk about somebody who is jumping on a trampoline on exactly this day in 2018, I would use present tense. I would say they're jumping on a trampoline right now. So everybody who can understand my words right now, you know what tense is, and now you are in a position to think about what the A series is. The A series is a way of thinking about times in terms of tense. It would order those times with respect to whether they are present times or past times or future times. The B series, in contrast, thinks of times tenselessly. And when you talk about the B series, you need to hear words like exist as not having any tense, not even a present tense. So there's just these moments in time, and things exist at those moments. So we would say something like the signing of the Declaration of Independence for the United States of America is at 1776. And that is, it might sound to you like present tense, but you're supposed to hear it as tenseless. So there's a tenseless way of thinking about times in which there's just when they happened. And relative to a particular time, so relative to 1992, 1776 is earlier than it, but relative to the year 500, it is later than it. It's neither, it's not intrinsically late or intrinsically early. It's just later or earlier, depending on what other moments in time you're talking about. On the A series, whether something is present or not is like an intrinsic feature of that moment. But on the B series, there's nothing intrinsically past or present or future. It's just relative to other moments. So given one moment and given some other moment, that one moment is in its future. And relative to some other moment, it is in its past. But there's nothing intrinsically past, present, or future about the moments in time in the B series. One way of thinking about time that you're probably very familiar with is to think about it in terms of diagrams, like, for example, timelines, or you're also used to making graphs in which we represent time spatially. So here's a very typical sort of thing that you've seen before. It's a timeline, and in this timeline, we're ordering the events in the life of Benjamin Franklin. So all the way here on the left, we've got the year 1700, and all the way here on the right, we've got 1800. And in here is when Benjamin Franklin is born on January 17th, 1706. Benjamin Franklin is born in Boston. Now, I could describe that event tenselessly. I could just say, it's at 1706 that Benjamin Franklin is born. That statement doesn't say anything about whether that's a past event or a future event. You might say, well, it's obviously a past event because it's 2018. Yeah, but I didn't say it was 2018. I just said he is born in 1706. So the statement itself is silent about what year it really is right now. So that would be to describe things tenselessly. That would be to describe things with respect to this B series. But the A series would be to describe things as being tensed and using tense language to describe them. So we would say things like, Ben Franklin has flown his kite. That's past tense. Or humans will fly to Mars. So you might say, yeah, what's this got to do with metaphysics? We want to know, as philosophers studying metaphysics, what is the true nature of time? And so far, all this stuff about tense just sounds like language. Like, who cares about language? We want to talk about reality. Well, one way of understanding these different proposals about reality in terms of tense is that, and let's go back to the A theories. The A theories are saying that tensed language is the most appropriate language for describing what's really happening with respect to time. If you wanted to, you could describe things in a B series sort of way, but that doesn't get at the real reality of time. The real reality of time has time as changing, and there's a real difference between the present, the past, and the future, a difference that tensed language best gets at. In contrast, B theories say that tenseless language is fully adequate for describing everything that's going on in time. There's nothing intrinsically past about the past. Relative to this moment, 1706 is in the past. Relative to the 1600s, 1706 is in the future. And there's no ultimate answer to the question, well, is it really in the past or is it really in the future? There is no really when it comes to past, present, and future. It's just relative. So you've heard of relativity theory, maybe, and it might make sense to you why relativity theory, the theory of Einstein, would wind up over on this B theory side of things. So one way of understanding what the big difference between the A theory and the B theory is in terms of the A series and the B series. And that all has to do with whether you're using tensed language or tenseless language to describe the different moments. And it goes beyond language. The language is just a metaphor for what is allegedly really going on with time. The A theorist says that time itself is intrinsically tensed. There's a real difference between past, present, and future that is beyond a mere relation between events. Where the B theorist says, no, all that past, present, tensed stuff is just piggybacking on what's really going on. What's really going on is that time is very much like space. And just like there's no real difference between here and there, there's no real difference between now and later. One way of stating what is important to the A theories, what defines the A theories versus the B theories, is to say that with the A theory, time changes. There is such a thing as real change, that time itself changes. There's really such a thing as what is known as temporal becoming, the future becoming the present. According to the B theorist, that doesn't make any sense at all. There's no such thing as time itself changing. All sorts of other things change, but that's just to state their relationships to time itself. But for the B theorist, time itself does not change. Now, when I first started talking about McTaggart a little bit ago, I mentioned that he had developed this language of A series versus B series as part of an argument against the reality of time itself. And let's take a quick look at his argument. So here's McTaggart's argument. Note, let's just race to the end. What's the conclusion of his argument? We could represent it as the statement that nothing exists in time. Maybe there's things that exist, but they don't exist in time. If this seems to you a little bit like Zeno, this might remind you a bit of Zeno. Remember Zeno's paradoxes about motion? And one interpretation of what Zeno was motivated by is that he was under the influence of his teacher Parmenides, who believed that there really isn't any change, that the real reality is singular. The only thing that really exists is the one, and the one is permanent and absolute and unchanging. The change itself is some sort of illusion. And we can see McTaggart's argument and its conclusion that nothing exists in time as being kind of part of a piece with Zeno and Parmenides, that if there is any time at all, it's just kind of an illusion. It's just in your mind. It's not really real. Okay, so let's look at the argument itself. And it helps to have in mind the difference between the A series and the B series. Oh, here's the thing. If any of you guys have iPhones and you use Siri and you talk to your iPhones by saying things like, "Hey Siri," well, don't talk about the A series because your phone is going to think you're saying, "Hey Siri." It happens all the time. So if I say A series, that there's Siri trying to get in on the conversation. Shut up, Siri. Okay. Yeah. So you know. So here we go. First premise. If any event has one of the following properties, being past, being present, being future, then it also has the others. Okay, that seems reasonable. If any event has one of the following properties, then it also has the others. You might be tempted to say, well, wait a minute. Let's take an event like something in 1984. So that's got the property of being past. Yeah, all right. Well, how about the property of being present? Well, it had the property of being present. So in some sense of having, it has the property of being present. And how about being future? Well, there was a time in which it was future. So I guess in a sense that's true, that every event has all those properties. Although you might think that something funny is going on here, right? Because you might say something that you might want to say something like, well, don't they just have these properties one at a time? And now we get to our second premise. And the second premise says, no event can have more than one of the following properties. So at any given moment, an event is either past or it's present or it's future. So it either has the property of being past or it has the property of being present or it has the property of being future, but it never has more than one of those properties. Okay, premise 3. No event has any of the following properties. Being past, being present, being future. That's supposed to follow from 1 and 2. So if any event has one of the following properties, then it also has the others. But you combine that with the statement that, well, it can't have more than one. So the only way out then is to say it has none of them. So it would follow then, if it doesn't have any of those properties, and those properties are what we call the A-series properties, it follows then that nothing really has any A-series properties. But if nothing has any A-series properties, then it doesn't exist in time. And you might say, wait a minute. Couldn't it still have B-series properties and therefore exist in time? But there's an assumption in this argument that that's not really time. That's not really real change. Everything is just kind of frozen. There's nothing flowing. Real time is when there's real change. So one interpretation of this argument is it's pointing out this tension in our philosophical thinking about time. On the one hand, we're tempted to say that time has to operate the way the A series says it does. But on the other hand, when we start thinking about it, it's just really weird and contradictory that it would have A series properties intrinsically. But then you think, well, then what time is just what the B series says it is. But then that just doesn't even seem like time. It's like, there's no time. There's just like this weird frozen manifold that has all these moments in it. Nothing is flowing. Nothing is changing. So it's very strange. It's very, very puzzling. Okay, so I got to be honest with you. You might find this incredibly confusing, and that's a lot of philosophy for you. Philosophy is not easy, and often if you feel confused, that means you understand it, because philosophy is dealing with things that is confusing to everybody, and even philosophers that have been thinking about this stuff for years and years and reading stuff that was written hundreds of years ago. There's like as a whole, philosophy is working on some of these problems for thousands of years, literally. And they're still confused. And you might say, what's the point of learning about things that are intrinsically confusing or confused? And the answer is, welcome to the human condition. We often have to operate in the face of uncertainty, where we just kind of don't know really what's going on. And part of being an adult is knowing how to go on anyway. And it's good to know what the limits of reason are and when reason leads into contradictions and puzzles. And even something as simple as time is itself concealing all sorts of weird little traps and puzzles. Anyway, let's talk about a slightly different aspect to all this, and some of you might think this is going to be more fun than what we've said so far, and that's time travel. Some of you might think this is more fun. Some of you might say, oh, this is even worse. It's even more confusing once you start thinking about some of these time travel stories and time travel ideas. So one way in which philosophers talk about time travel, as I mentioned a little bit earlier in the video, is by trying to debate whether it can be known a priori that time travel is impossible, or whether instead it can be known a priori that it might be possible. You might say, who cares about the a priori? Let's just go do some science and see if we could build a time machine and make it work. And that's great, knock yourself out, but this is not a science class, it's a philosophy class. You're going to learn about what you can accomplish philosophically with respect to these various topics. So these various a priori arguments, pro and con, concerning time travel, circle around various paradoxes that are alleged to arise when you start getting into time travel stories. And some of these might be familiar to you if you've seen various movies, like, for example, Back to the Future, or Looper, or Primer. There's some really good science fiction out there. Maybe some of you are into Doctor Who, and there's lots of time travel and time travel paradoxes that arise. We're going to talk about just some of the main puzzles or paradoxes that arise when we talk about time travel. So one of them is something I'm going to call Lewis's paradox. In contemporary philosophy, and by contemporary I mean like the past 100 years, one of the greatest contributors to the literature about the philosophy of time travel is David Lewis, and he talks about this paradox that we could call Lewis's paradox. And one way of stating the paradox is that we've got two events that are separated by unequal amounts of time. What does that mean? Well, take, for example, a pair of events that define the beginning and end of a time travel voyage. So let's say you look at your watch and it says 10:09. And you get in your time machine, you start a time machine journey, and you go 100 years into the future. Now, inside the spaceship, or inside your TARDIS, inside your time machine, you're looking at your clock and only a minute goes by. And after a minute elapses, it's now 10:10. You step out of the machine and there you are, 100 years in the future. Now, we've got two events that we could talk about the time separation between. So the first event is the beginning of the voyage, and the second event is the end of the voyage. What amount of time separates those events? On one point of view, what separates those events is 1 minute. From your perspective, looking at your wristwatch, that journey only took 1 minute. But from an external perspective, that journey took 100 years. The beginning of the journey was 100 years earlier than the end of the journey. And that's a paradox, because you might think that two events can only be separated by one amount of time. They can't be both 100 years and not 100 years long. Probably more famous and more weird is the grandfather paradox. And the grandfather paradox doesn't have to be about grandfathers, but that's just an illustration of what's going on here. So suppose there was a time machine and you went back in time, and you met one of your grandparents, and you met them before they had gotten pregnant with with one of your parents. So suppose, like, way before your biological father was born, you went back in time and met your biological father's biological father. And then for reasons I don't have to go into, maybe there was just an accident or maybe an argument that got out of hand. You killed your grandfather. You killed your grandfather before he had a chance to help your biological grandmother get pregnant with your biological father. So, if the grandfather died before that crucial birth, namely your birth, you would have never been born. If the grandfather died before impregnating the grandmother, then your parent would never have been born, and so you would have never been born. But if you were never born, then you were never able to go back in time and kill the grandfather. So great, grandfather's okay. He can go and do the thing that he was going to do, and that is to get grandma pregnant. And so you are born, so you are able to go back in time. So you kill grandpa, so you can't go back in time. You might say this is very confusing, and you would be right. It is very confusing. The proposal is that you go back in time and you make yourself not be able to go back in time. But that's a flat out logical contradiction. You cannot make yourself not exist. Let me put it like this, because you might say, well, what about suicide? Isn't that making yourself not exist? I'm like, how about this? No. What you can't do is make yourself never have existed. Because in order to make anything, in order to make yourself or anything else do anything at all, you have to exist. So you can't make yourself have never existed. That would be a flat-out logical contradiction. But the grandfather paradox is saying, like, look, let's just by hypothesis, for the sake of argument, let's suppose there is time travel to the past. And let's also suppose there's such a thing as free will. And you might start to appreciate that maybe the solution to all this stuff is to just get rid of free will. And when we get to our free will unit, you'll see various metaphysical arguments for why maybe metaphysically speaking, there's just no such thing as free will. There couldn't be such a thing as free will. But assuming for now that there is such a thing as free will, you might say that one of the things that you're free to do if you go back to the past is kill your grandfather. But that would lead then to this contradiction, which is that you are causing yourself to have never existed. That's impossible. There cannot be a contradiction in real reality. What led to that contradiction? Well, what led to that contradiction was the supposal of, number one, time travel to the past, and number two, free will. And you might say, well, I don't want to give up free will, so in order to resolve this, we're going to have to get rid of time travel to the past. And that's how the grandfather paradox plugs into an argument against time travel. A closely related paradox is something that some people have called the Hitler paradox. There's lots of time travel stories in which someone gets hold of a time travel machine and, well, what are you going to do with it? You're going to do something to benefit society and the rest of the world, or you're going to do something to just benefit yourself? And a lot of people say, we want to go back in time and kill one of the most evil people ever before they can get up to their bad actions. And a very familiar and popular target is Hitler. So you go back in time and you shoot baby Hitler, or maybe you drop kick baby Hitler. And then so what? So what happens is Hitler never gets World War II going. There's never the Holocaust. There's never the concentration camps. There's never all the various soldiers that died in battle trying to stop the Germans. So you would presumably do a lot of good if you went back in time and you killed Hitler before he even grew up. While he was still a baby, you killed him. But now, wait a minute. If Hitler never made it beyond being a baby, then World War II would have never happened, and you would have never heard of Hitler. No one would have heard of Hitler. It'd just be some, this baby that died under mysterious circumstances. Or maybe you kill him a little bit later in life, and he was just an artist. He's just this painter hanging out in Europe, and he died. How did he die? We don't know. Rock fell on his head. Don't know how that happened. He would have never started World War II, and so he would have never become famous. You would have never heard of him, so you would have never been motivated to go back in time and kill him. The Hitler paradox is essentially the same as the grandfather paradox. It's just a different example of the essential same thing. And the same thing is that you would be going back in time and preventing yourself from going back in time. And that's a logical contradiction. With the Hitler paradox, you're preventing yourself from going back in time by making Hitler never have been a bad person, and so therefore you would have never heard of him, and so you wouldn't have gone back in time and killed him. And so since you didn't kill him, he did go ahead and get World War II started. So you do hear about him, so then you do go back in time. It's really logically the same as the grandfather paradox. In both the Hitler paradox and the grandfather paradox, what you're doing is you're changing the past in ways that would prevent you from ever having changed the past. Okay, here's another paradox that has to do with time travel. And in many ways, this one is weirder, way weirder than the grandfather paradox or the Hitler paradox. So the bootstrap paradox is one name for this. Another description or name for this is a causal loop paradox. And one way to illustrate it is with respect to various time travel stories. Here's one that I made up. So imagine this. Imagine one night you're trying to get to sleep and you hear a knock on the door. And you go and answer the door and there's no one there anymore, but there's this envelope. And you open the envelope and there's a letter in there and there's some blueprints in there, and you read the letter and it says, follow these instructions, follow the blueprints, and build the machine described therein. And then press the on button when you're done. So in this story, you know how to build machines, okay? And you follow the instructions and you build the machine. You had enough parts laying around in your bedroom, and you finish this up overnight, and you push the on button. And the first thing that happens is a TV screen activates, and you see an image of your own face, and it starts talking to you, and it says, "Hello, I am you from the future, and I need you to take this machine, which is a time machine, and go back in time a few minutes or an hour or whatever, and knock on the door and leave the envelope." Okay? And so you like, all right, I guess I'm going to do that. Why do you obey your future self? Look, it's a story, and you do that, okay? So you push the next button, and that sends you back in time, and you deliver the envelope to your past self. Okay, so where did this time machine come from? Well, in some sense, you built it. You built the time machine. Okay, how did you build the time machine? Well, you built it based on the blueprints that were in the envelope. Okay, where did the blueprints come from? Answer, they were delivered to you by your future self. Well, where did your future self get them? Well, from your past self. Your past self built the time machine following the blueprints and then went back in time and delivered them. Well, how did the blueprints come to be? Did anyone sit down and draw the blueprints? Nope. There's no point in time in which someone draws the blueprints. There's just these moments in time where there are no blueprints, and then there's a moment in time in which there are blueprints. The earliest moment in time, looking at this from like God's eye point of view, the earliest moment in time in which the blueprints exist is when they're in that envelope on your doorstep. There's no earlier moment in time. And you might say, well, wait a minute, before they were delivered, like, didn't you step into the time machine and go back in time? Yeah. But from an external point of view, that happened later. So what caused the blueprints to arrive is some future event, the future event of going into the time machine. They weren't caused by any past event. And further, there's no moment in time in which the blueprints are drawn. They're never created. So one way of describing the bootstrap paradox is to say that it's a case in which we have information or objects that exist without having ever been created. Another illustration of this is from the Terminator movies. Some of you may have seen the Terminator movies. And in the Terminator movies, you know the basic thing that's happening is that there's a war between robots and humans, and a lot of the action of the movie is happening in the present, and we see present day people that are fighting against robots from the future. Now, the robots from the future, they were created by an artificial intelligence called Skynet. Well, where did Skynet come from? Skynet was made by the human military. Way before there were any of these killer Terminator robots, there was the U.S. military, and it made an artificial intelligence called Skynet that was supposed to protect the United States against missiles from Russia, something like that. Okay, so Skynet was a really smart artificial intelligence. It got so smart that it decided, you know what? I'm going to drop kick all the humans. Let's get rid of humans. Question, where did Skynet come from? Where did that Skynet technology come from? Well, if you remember the Terminator movies, it was revealed that the microchip, which was the basis for the Skynet artificial intelligence, came from out of one of the heads of one of the Terminator robots, like maybe the Arnold Schwarzenegger robot. So Skynet was never invented. The humans that built Skynet were just plagiarizing the microchip that they got out of the Terminator. Where did they get the Terminator robot? Well, the Terminator robot traveled back in time. The Terminator robot was built by Skynet in the future. And Skynet itself was based on a microchip that had a design that was never invented. So there's just this loop in time. This past moment came to be because of this future moment, and the future moment comes to be because of the past moment. You've got this looped causation. And in that loop are these items that were never created. No one ever invented the microchip, just like no one ever wrote down those blueprints. They're just passing them through that loop. Okay, so we could take these various paradoxes and plug them into an argument form and create an argument against time travel. So let's take one of the paradoxes, like, for example, the grandfather paradox. And we could plug the grandfather paradox in where the blue text is located. So if time travel is possible, then you could go back in time and kill your grandfather before you were ever born, and so therefore make yourself not be able to go back in time and make yourself not be able to go back in time. However, that's a contradiction. However, that grandfather paradox cannot actually happen, so therefore time travel is impossible. By the way, this argument form, this general argument form, is an argument form that we're going to see a lot in this class. And it's an argument form that if you study logic, you would know that its general form is something called modus tollens. And a modus tollens argument has the form if P, then Q. That's the first premise. Second premise, not Q. And the conclusion is not P. So we're saying if this thing is true, then this other thing would be true. In the second premise, you say that other thing couldn't be true. So therefore, the first thing can't be true. This is the same argument form as the argument form that's used in the argument from evil against the existence of God. If God existed, then there wouldn't be any evil and suffering. But there is evil and suffering, therefore God doesn't exist. One thing we know about arguments of that form is that they are valid, meaning that if the premises were true, then the conclusion would have to be true. It's a valid argument. So here's what you get when you take that argument form, which is a valid argument form, and you plug in stuff about killing your grandfather. If time travel is possible, then you can prevent your own birth by assassinating Grandpappy. However, you cannot prevent your own birth by assassinating Grandpappy. Therefore, time travel is impossible. Or we can do that with the bootstrap paradox. If time travel is possible, then a complex object could exist without ever having first been assembled out of comparative simples. However, a complex object cannot exist without having first been assembled out of comparative simples. Therefore, time travel is impossible. Okay, we could have a whole semester just about the philosophy of time travel, and that probably would be really, really cool class. At least from my point of view, I'd enjoy that class. And maybe you would too. So we're not going to be able to say everything that you could say about time travel in this lecture, but let's briefly wrap it up and relate some of the stuff about time travel to the B theory. One of the most important things that you could get out of the B theory is the way in which the B theory thinks about change. And the B theory takes this definition of change and uses it to resolve the paradoxes and show that, in a sense, then time travel is possible overall. So let's think about change. Suppose someone were to invite you to define change. What would be a definition of change. And in the broadest sense, what does it mean for things to be changed or to be changing? You might say, that's hard to define. I mean, change it's just happening all the time. How would you define it? But we can think about different examples of things changing. Like, for example, my hairstyle has changed. How much I weigh has changed. I've gained a lot of weight in my life. I have gained a height. I used to be a tiny, tiny little baby, and now I'm a 6 feet tall old man. So all sorts of things change. My house has changed. It used to have a nice fresh coat of paint, and now the paint is falling off. Whenever things change, what's going on there? And one way you could describe what change is when there is one thing that has two different properties at two different times. So, for example, I changed my hairstyle. So right now I've got, I don't know what you call this hairstyle. Let's call it a floof. I got the classic floof. But suppose I went and I got a mohawk. So I changed this one thing, my hairstyle, from a floof to a mohawk. But now, what if you had a mohawk and I had a floof? That's a difference, but that's not change. It would be change if it was one haircut that was in two different styles. Or if you're 4 feet tall and I'm 6 feet tall, that's a difference, but it's not change. It's only change when we're talking about one thing which has two different heights. And it's got to have the two different heights at two different times. There might be an object that is 4 feet along one direction and 6 feet along another direction. So that's one thing that has two different heights, but it has them at the same time. So that's not change either. Change is when you've got one thing that has one height at one time and another height at another time. So we could summarize this by saying that what change is when one entity has two different properties at two different times. Okay, so what does this have to do with anything? Especially, what does it have to do with the metaphysics of time? What does it have to do with the questions about time travel and whether time travel is possible? Well, one of the biggest bones of contention between the A theorist and the B theorist is the question of whether time changes. And in the various time travel paradoxes, it looks like you're dealing with trying to change the past. You might say that there used to be a live, living grandfather, but then you went back and made him die before he could get married to grandma. There used to be this terrible dictator in Germany who created World War II, but then you went back in time and drop-kicked baby Hitler, and so that never happened. It looks like you're changing the past in those cases. But wait a minute. Let's take this definition of change and ask ourselves, does it even make sense that you could change the past? An entity changes if and only if that entity has two different properties at two different times. If you can change a haircut, then a haircut can have two different properties at two different times. You might say, yeah, right. If you could change a person's height, then that person can have two different heights at two different times. Yeah, fine. Right, we get that. But what does this have to do with time? Well, if you could change the past, like you could change the past moment in time, like say July 4th, 1776, we go back and we shoot everybody before they can sign the Declaration of Independence. If you can go back and change the past, then that means that past moment must have had two different properties at two different times. So at one time, the Declaration of Independence is signed, and at another time, it never was signed. But wait a minute. How can one moment in time, namely July 4th, 1776, be at two different moments in time? That seems like a full-blown logical contradiction. There's only one time that July 4th, 1776 can be at, and that is July 4th, 1776. So July 4th, 1776 cannot change, and the reason that it cannot change is because it cannot be at two different moments in time. The only moment in time it could be at is itself. So time cannot change. The definition of change is when something has two different properties at two different times, but a time itself can only be at its own time, and so therefore it cannot change. What does this have to do with the time travel paradoxes? Well, what it has to do with the time travel paradoxes might be spelled out like this. We ask ourselves, according to that B-theoretic definition of change, can a moment in time change? We realize a moment in time cannot change. So, if it was true that a moment in time cannot change, and if it's true that you were born, I mean, in my case, I was born in 1969, then that's the end of the story. In 1969, December 22nd, Pete Manick is being born. The end of the story, December 22nd, 1969, can never change to not having Pete Manick ever been born. Because you can't change a moment in time. So, can you go back in time and kill your grandfather? No. If your grandfather wasn't killed by a time traveler, then he wasn't killed by a time traveler. If you were born, then you were born, and you cannot go back in time and make yourself have never been born. How about the bootstrap paradox? How do we resolve the bootstrap paradox? Well, one way of thinking about this is, since there's no change, time doesn't change, moments in time don't become. So you have to rethink what causation is. You shouldn't think about causation in terms of there's this one moment in time and then it makes this other moment in time become. So, for example, if I mix up some flour and sugar and water, make a cake, we don't have one moment in time where there is no cake, just a bunch of unmixed flour and sugar, and then some other moment in time that is made to become. What's really happening is that you've got this one moment in time where there's a bunch of unmixed sugar and cake. A bunch of unmixed sugar and flour, and then this other moment in time where there's a cake, and causation just is a relationship between those two moments. There's no real change, at least not with respect to time. Time itself does not change. That moment in time with the cake in it always was going to have the cake in it, and afterwards it always will have had the cake in it. That's, in some sense, eternal. And the other moment in time that is cakeless was always going to be cakeless, and it always will have been cakeless. So you've got one moment in time which is cakeless, and another moment in time which is caked. It has cake in it. And to say that there's a causation going on is just say there's a certain kind of relation between those two moments in time. And that relation, usually we're used to it, the causal relation being such that causes are earlier than their effects. But why not have sometimes the causes are later than their effects? Why not it be the case that sometimes an event in time is the effect of something that happens later? There's nothing logically contradictory about the so-called bootstrap paradox. One interpretation of this is to say that bootstrap paradox isn't actually a paradox. There are some things that they exist at one moment in a particular moment in time, and the other moment in time, which is their cause, exists at a later moment in time. That's what's happening with the so-called circular causation of taking a time machine and sending it back in time so that you can have a time machine and go forward in time to then again deliver the time machine. So there's no contradiction in the bootstrap paradox according to this B theory interpretation. And with the grandfather paradox, well, you wouldn't be able to kill your grandfather. Why not? Is it because you don't have free will? Well, in one sense of free will, no, you don't have free will. if what you mean by free will is to be able to change moments in time, like to make the future be one way versus another, then there's no such thing as free will. And you can't change any moment in time. You can't change the past, you can't change the future, you can't change any moment in time. Why not? Well, it's just the definition of change. The definition of change is when an entity has two different properties at two different moments in time. But a moment in time cannot be at any other moment in time besides itself. It can't be at two different moments in time. So that's the way the B theorist resolves the time travel paradoxes. The B theorist is, like, for example, David Lewis, showing that time travel is possible. And that makes sense. The B theory allows there to be times to travel to. In some sense, the future already exists, so you could travel to it. And in some sense, the past still exists, so you could travel to it. On an A theory, like especially presentism, time travel wouldn't make any sense. Like, if the only moments in time that are real are the present moment, then there's no past to go back to, and there's no future to go forward to. On a growing block theory, I guess you could go back in time, but you couldn't go forward in time. And on a shrinking block theory, you could go forward in time. There's no past you can go back to. So, in some sense, B theory fits the best with all these various time travel scenarios. All right, that was a lot. That was a lot to absorb. Let's wrap it up with some study questions. Study question 1. Which would most likely agree with this statement? A moment in time cannot itself change. A, the A theory of time. B, the B theory of time. Which one would most agree with that statement? Study question 2. Which would most likely agree with this statement? Tensed language best gets at the fundamental nature of time. Would it be the A theory that agrees with that, or would it be the B theory? Study question 3. Which time travel paradox is best defined by the following? Going back in time and causing yourself to be able to go back in time. Does that sound to you more like the grandfather paradox, or does that sound to you more like the bootstrap paradox? Well, what you should do is think about these and see what you would answer, and then see if you got the right answer. And here come the right answers. The right answer to study question 1 was B, and the correct answer to study question 2 was A, and the correct answer to study question 3 was B. And that brings us to the end of time. Okay, everybody, I will see you in the future. Have a good one.